on with this radiation sheet, but like previously, what we'll do now is we'll summarize what we know so far. Yeah? Half-life is the time taken for the activity of a substance to halve. That's the definition of half-life. What is the unit of activity for radiation? Unit of activity. So when something's radioactive, we measure it in becquerel, BQ. In the same, we measure mass in kilograms and time in seconds and distance in meters. We measure radioactivity in becquerel. Right, we know beta decay is the loss of an... Whoa, what's going on? The beta is the loss of an electron when a neutron splits into a proton and an electron. The electron sort of disappears off into the wilderness, and that's the beta decay. Right, alpha radiation is a helium atom, basically the helium nucleus. That's right. Beta is an electron, and it'll come in this symbol. Zero mass, or so small, negligible, so small that they ignore it. But it's got a charge of -1, -1. And then you've got gamma radiation, which is has no mass, no charge, and is just a pure electromagnetic wave. So it's known as electromagnetic radiation. Right. Alpha particles can be stopped by paper. Beta and alpha particles are both stopped by aluminium, and gamma is stopped by thick lead. If it's thin lead, it'll still get through, but beta and alpha will be stopped by lead as well. Right. Fission is the splitting up of a nucleus. Fusion is the joining of two nuclei. Two, right? Not two nucleus. Two nuclei or two nucleuses. You've got to make sure that you want plural. So it's better to put the word two in. As long as the marker knows your intentions that it's more than one. Right. Let's go, 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 go. Go, 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 go. We stopped here then. Right. Which statement describes the term atomic number? Do you know with chemistry and physics they're slightly different? They use the word nucleons and da-da-da, so we've got to get used to that. Right. Number of electrons? No. Number of neutrons? No. Number of protons? Yeah. Which statement describes the term mass number? In chemistry, they tend to use the word relative atomic mass. Here they're saying it's mass number. So it's the number of protons and neutrons in a nucleus. Okay. Which statement describes the term isotopes? Isotopes. They are atoms that have the same number of protons. So this is coming from chemistry, but different number of neutrons. Right. Which statement describes the term isotopes? Right. Same number of protons, but different number there. D. So you just got to read through them carefully. So it's C, D, D. An atom contains 8 protons, 8 neutrons, and 8 electrons, which would result in a negatively charged ion of the same element. if you add an electron. Right, let me just try to draw this out. So just say this is element X. Right, it's got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's got 8 protons, the positive red ones, 8 neutrons, the green neutral ones, and it's got 8 electrons. So remember, we know there's, I'm going through this slowly, so then this is good for chemistry anyway. 2, you're only allowed 2 in the first electron shell, and you're allowed 1, 2, you're allowed 8 there, but we only need 1, 2, 3, 4, 5. So all together, look, we've got 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now, which would result in a negatively charged ion. So we need to add, if we add an electron, let's add an electron, so that's an extra minus. Before we had 8 pluses and 8 minuses. That equals 0 if you cancel each other out. So if we add one more negative, our overall charge is -1 or negative. Right, let's move on. It is not possible to predict exactly when radioactive nucleus will decay. Which feature? Right, it's random. Yeah. It's a random event, so you won't, yeah. It's another way of saying they don't understand it. That's what the word random means. They don't understand it. But we're not interested in that. All we want to know is that it's random. Which of these is the correct unit for measuring activity? Right. That's power, that's energy, and that's charge. And it's becquerel. That's the one. Right. Do you think we can get through this? Yep. The material granite is used for work surface in a kitchen. It contains radioactive isotopes, so it contributes to the background radiation in the kitchen. Give another, right, okay. What are the other sources of, now can you see it's repeating this, so what are the other sources of background radiation? The most obvious one that I know is sun, radon gas in the air. You've got it from the sun, radon. You've got it, some rocks can be radioactive. You can have nuclear waste. You can have any nuclear accidents. But look, stick to these. Next one, granite contains an isotope 232. What did we say an isotope was? Atoms, we're doing the physics definition, that have the same number of protons but different number of neutrons. Right. Thorium-232 decays by a sequence of alpha decays and beta decays to form radon-220. State two differences between alpha and beta. Oh, right. Beta radiation is an electron. Alpha radiation is a helium atom or helium nucleus. So what they've said is alpha has more mass. It has a positive charge and it has a shorter range in air. It is slower and less penetrating. Right, on the other side, okay, beta is has a negative charge. It has a low negative charge. It's -1 as opposed to +2. It has a longer range. It is right. Okay, so what we can say on this one, the alpha particle is a helium nucleus, whilst a beta particle is, what is a beta? Is an electron. I think we've got that at the top. Yes, we have. Right, that's fine. So we know an alpha particle is so we've got 86, 87, 88, 89, 90. So we need two of these. No, 86, 32, 20, 4, 8. No, we need three of these because everything has to balance up. Because look, here you've got each one alpha particle's got a mass of 4. 4 times 3 is 12. 12 plus 220 is 232. So you've got 90 and 86. 86, 3 times 2 is 6. 86 plus 6 is... What's 86 plus 6? 92. But we've only got 90 here, so we need a -1 here, -2. We need two of them. Right, I'm sure. Let me rub all this. Oh, did I just rub that 3 out? If you now tot up the numbers yourself, you will see that they add up. So I've got, okay, let's have a look at that. No, yeah, there you go. That's 220 plus 3 times 4 is 12 plus 2 times 0 is 0 equals 300, 230. No, I can't count. 232. Right, let's look at the bottom. 86 plus 3 times 2 is 6 plus 2 times -1 is -2 that's 92 minus 2 is 90. So they both balance out. Oh, that's a weird one, but hey, it's got to be done. We've got to Get ready for this. Right. Thorium is a solid. Radon-22 is a gas. Thorium and radium both emit alpha radiation. Discuss the hazards due to the granite. Refer to contamination and irradiation. Right. What we want to do is we need to look at these two definitions. Let me just go get hold of. Right. This is a bit of a head scratcher, but it's only 3 marks. I've been looking at them, asking me to do my head in as to how to word this. Right. Right. We know alpha particles are ionizing and can damage cells and can cause cancer. Right, we know that. Alpha particles, right, are only ionizing or dangerous when inside the body. So if you consume it inside the body, right, and can be, remember, they're not very penetrating. A sheet of paper can stop them and can be blocked by the skin. I mean, it doesn't mean that the skin's not going to get damaged. Right. Right. Thorium. This is what they've said. Thorium remains in the work surface. Thorium will irradiate food on the surface of the worktop, because you've got your worktop, your granite worktop. You've got thorium here in the worktop that will emit alpha radiation. So if you're cutting food on here, it will irradiate that. Normally they irradiate food to kill bacteria. Now you've also got radon, but that will emit itself as a gas. That's going to be a bit more dangerous because you can inhale that, whilst this stays in the worktop, whilst that can get into your body. Right. Right. Okay. So we've got that. What else do we need? Radon gas. Radon gas can cause irradiation of the food and can contaminate the surrounding environment. Can contaminate the surroundings because it can escape. It can escape into the air and will be breathed in. You will breathe it. You will breathe it in, and it can cause damage in the body. Radon gas can enter the body. Thorium cannot, because it doesn't penetrate the skin, it doesn't get into the skin, and you can't breathe in, cannot enter the body. So they only want 3 out of all of these. So with this sort of question, you must know alpha particles are ionizing, can cause cancer. They're only dangerous when in the body and can be stopped by the skin. But you can irradiate the food. That means food that's been exposed to radiation deliberately to cause it to kill off bacteria, to sort of sterilize it, if that's one for a better word. Right, radon gas is airborne and can enter the body because it can escape into the air and be breathed into the lungs. Thorium cannot do that. So it stays on the surface of the worktop. Right, okay, what else is there? Right, we'll call it quits there because that's a long one.